So here we have the function log of x squared plus x plus 1 divided by log x squared minus x plus 1. So we have to find the derivative of this particular function with respect to x. But before doing that, so we are going to simplify the given logarithmic expression. So we have log of a over b. So we know the log of a over b is given by log of a minus log of b. So we're going to apply this. So this is going to give us log of x squared plus x plus 1 minus log of x squared minus of x plus 1. Now we're going to apply the derivative here. So we have derivative of log of x squared plus x plus 1 minus derivative of log of x squared minus x plus 1. Now for the first derivative, we are going to assume that if x squared plus x plus 1 were equivalent to x, then we have the derivative of log of x, which would be simply equals to 1 over x squared plus x plus 1. But since it is not, so we are going to multiply it to the derivative of our assumed value, which is x squared plus x plus 1. Similarly, for the second derivative, we have 1 over x squared minus x plus 1 times the derivative of the assumption that we have x squared minus x plus 1. Now let us find this value. So we have 1 over x squared plus x plus 1 multiplied to, so derivative of x squared is going to be 2x plus the derivative of x, which is 1, plus derivative of 1, which is 0, minus 1 over x squared minus x plus 1 multiplied to derivative of x squared, which is 2x, minus derivative of x, which is 1, plus derivative of 1, which is 0. So that gives us 2x plus 1 over x squared plus x plus 1 minus 2x minus 1 divided by x squared minus x plus 1. So this is the derivative of the given function with respect to x. So we can go ahead and simplify this particular expression. So we can combine the two fractions to rational functions, and that should give us, so we have x squared plus 1 plus x. So this is the first denominator multiplied to x squared plus 1 minus x, which is the denominator of the second rational function. So we have in the numerator 2x plus 1 multiplied to x squared minus x plus 1 minus 2x minus 1 multiplied to x squared plus x plus 1. And that will give us, so we have 2x multiplied to x squared, so that will be 2x cubed, minus 2x times x, that will be 2x squared, plus 2x times 1, which is 2x, plus x squared minus x plus 1. So this will be, so we have minus 2x times x squared, which is 2x cubed, plus 2x squared, plus 2x, minus x squared, minus x, minus 1, whole divided by, so we have a plus b times a minus b, so this can be rewritten as x squared plus 1 whole squared minus x squared. So we get 2x cubed minus 2x squared plus 2x plus x squared minus x plus 1 minus 2x cubed minus 2x squared minus 2x plus x squared plus x plus 1 whole divided by, So now we're going to expand x squared plus 1 whole squared, so that will be x raised to the power of 4 plus 2x squared plus 1 minus x raised to the power of 2. So 2x cubed and negative 2x cubed gets cancelled. 2x and negative 2x gets cancelled. Negative x and positive x gets cancelled. So that leaves us with negative 2x squared minus 2x squared, which is negative 4x squared. Then we have plus x squared plus x, so that's positive 2x squared plus 2 divided by x raised to the power of 4 plus x squared plus 1. So finally we get negative 2x squared plus 2 divided by x raised to the power of 4 plus x squared plus 1. So this is the derivative of our given function with respect to x. Now let's move on to the next question. So here we have the function x times sine 2x plus 5 raised to the power of x plus 10 squared x whole cube. So let's try to find the derivative of this particular function with respect to x. So what we're going to do is first we are going to apply the derivative to each of the terms. So we have derivative of x sine 2x with respect to x. So this will be the first derivative plus derivative of 5 raised to the power of x plus derivative of, so here we have 10 squared x whole raised to the power of 3, which can be also written as 10x raised to the power of 2 times 3, which is simply 6. Now here we're going to treat x as the first function and sine 2x as the second function. So that will be equals to x times the derivative of the second function, which is sine 2x, plus the second function multiplied to the derivative of x, plus the derivative of 5 raised to the power of x, plus derivative of tangent of x raised to the power of 6. Now we apply the chain rule and then find the derivative for the functions. So we're x times, so here we have sine 2x. So if we assume that 2x is equivalent to x, then the derivative of sine 2x must give us cosine of 2x. But since 2x is not actually x, so we multiply it to the derivative of 2x plus sine 2x multiplied to the derivative of x, which is simply 1, plus derivative of 5 raised to the power of x is 5 raised to the power of x times natural log of 5, plus, now here we're going to apply the power rule by assuming that tangent of x is equals to x. So we have derivative of x raised to the power of 6. So that should give us 6 times tangent of x raised to the power of 6 minus 1 times, so we apply the chain rule here, so this will get multiplied to the derivative of the assumed x, which is tangent of x. So we finally have x times cosine of x, cosine of 2x times derivative of 2x is simply 2, so we have 2x cosine of 2x plus sine 2x plus 5 raised to the power of x times log of 5 plus 6 times tangent of x raised to the power of 6 minus 5 is, or 6 minus 1 gives us 5, times derivative of the tangent function is secant squared x. So this is the derivative of our given function with respect to x that has been determined by using the chain rule. Let's move on to the next question. So here we have the function 3 times e raised to the power of negative 3x multiplied to log of 1 plus x. So let's try to find out the derivative of the given function with respect to x. So here we're going to treat 3 being a constant, we can we're just going to keep it as a constant and pull it out of the derivative. So this time we're going to assume that e raised to the power of negative 3x is the first function and log of 1 plus x is the second function. So that gives us 3 times the first function, which is e raised to the power of negative 3x multiplied to the derivative of the second function, which is log of 1 plus x plus the second function, which is log of 1 plus x, multiplied to the derivative of e raised to the power negative 3x, which will be equals to 3 times e raised to the power of negative 3x. So derivative of the logarithmic function is, if we assume 1 plus x to be equivalent to x, then we should get 1 over 1 plus x. But since it is not, so we need to multiply it to the derivative of 1 plus x plus log of 1 plus x multiplied to derivative of the exponential function gives us the exponential function itself multiplied to the derivative of the assumed function x, which is negative 3x. So that gives us finally 3 times e raised to the power of negative 3x multiplied to 1 over 1 plus x. Derivative of 1 is 0 plus derivative of x is 1 plus log of 1 plus x times e raised to the power of negative 3x multiplied to derivative of negative 3x is simply negative 3. So we can take e raised to the power of 3x, negative 3x as the common factor. So we already have 3 common. So that leaves us with 1 over 1 plus x minus 3 times log of 1 plus x. So this is going to be the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function x squared plus 2 divided by the square root of cosine of x. So let's try to find out the derivative of this particular function with respect to x. So we're going to apply the quotient rule here. So we have square root of cosine of x in the denominator. So we square it, then we begin with the same denominator in the numerator. So we have square root of cosine of x multiplied to the derivative of the numerator, which is x squared plus 2 minus x squared plus 2 multiplied to the derivative of the function in the denominator, which is cosine of x raised to the power of half. So we get square root of cosine of x multiplied to derivative of x squared is 2x plus derivative of 2 is 0 minus x squared plus 2 multiplied to, so here we're going to apply the power rule. So we have cosine of x, so if we assume that it is equivalent to x, then we have x raised to the power of half. So that gives us half multiplied to cosine of x raised to the power of half minus 1, which is negative half, multiplied by the derivative of cosine of x, whole divided by cosine of x. So we have twice of x times square root of cosine of x minus x squared plus 2 divided by 2 times, so cosine of x goes to the denominator and it becomes cosine of x raised to the power of half, multiplied by derivative of the cosine function, which is negative sine x, whole divided by cosine of x. So we now have 2x times square root of cosine of x minus x squared plus 2. So the negative and negative sine x will make it positive. So we have x squared plus 2 multiplied to sine x divided by 2 times the square root of cosine of x, whole divided by cosine of x. Now we're going to multiply both the numerator and the denominator by 2 times square root of cosine of x. So that gives us 2 times 2 will be 4x. So square root of cosine x multiplied to square root of cosine x will give us simply cosine of x. Plus, so 2 times cosine, square root of cosine of x when multiplied to the second term. So it cancels out the term in the denominator, leaving us with x squared plus 2 times sine x whole divided by 2 times cosine of x multiplied to square root of cosine of x. So this is the derivative of our given function. Let's move on to the next question. So here we have the function sine squared log of 2x plus 3. So let's try to find out the derivative of this particular function with respect to x. Before that, we are going to rewrite our sine function as sine log of 2x plus 3. So we're going to put a whole square to it such that we can apply the power rule. So we're going to consider the entire sine function as x. So that should give us 2 times sine log of 2x plus 3. Now this was our assumption, so we need to multiply it to the derivative of our assumed x, which is sine of log 2x plus 3. Now the derivative of the sine function, assuming that log of 2x plus 3 is equals to x, so that should give us cosine of log of 2x plus 3, and we multiply it to the derivative of log of 2x plus 3. Now we are going to apply the derivative to the logarithmic function by assuming that 2x plus 3 is equivalent to x. So that should give us, so the derivative of the logarithmic function is 1 over 2x plus 3, and this will be multiplied it to the derivative of 2x plus 3. So that gives us finally 2 times sine log of 2x plus 3 multiplied to cosine of log 2x plus 3 times, so derivative of 2x is going to give us 2, and derivative of 3 is 0, so we have 2 over 2x plus 3. So finally we get 4 over, so here what we can do is this is an identity, so we have 2 times sine theta times cosine of theta. 2 times sine theta of cosine theta is equals to sine of 2 theta. So we can combine it and rewrite it as, so 2 over 2x plus 3 multiplied to sine. So we have 2 times log of 2x plus 3. Well, we can rewrite it as 2 over 2x plus 3 multiplied to sine log of 2x plus 3 whole squared. So this is the derivative of the given function with respect to x.